Okay, hi all. Hope everybody can hear me, see me. Let me know if you can hear me, you can see me, and I'll begin. Today has been crazy. The last couple days have been crazy. It's very hard to even stay on top of it all. Um, I have behind me my newest version of my space weather snapshot. Some of you have seen me. I've literally, this is the first time I've had to update it every single day because things are changing so dramatically. Good. Paul Griffin, you say you can see and hear me? Wonderful. Spock's daughter, fantastic. Good to see you guys. Thanks so much for joining. I really appreciate it. Um, yeah, today has been, well, the last couple days, about the last 48 hours, has been pretty spectacular. For any of you who have actually seen and watched my latest forecast, great. Watch it for archival purposes because it's completely worthless now. The sun has done it again and absolutely made it completely obsolete within a couple days of even putting it out. The fast solar wind has been disrupted. That fast solar wind that we were anticipating has been disrupted kind of on and off. We are getting some of it, but believe it or not, because of all the activity of the sun here, it has been it's been kind of pushed away or just kind of blocked to some degree. And what we've gotten instead are just a myriad of solar storms from these two regions right here, which I'll go into the details in just a second. So let me jump out of the way so that you guys, for those of you who are super busy and don't want to have to wait for a long time, I thought I'd put the space weather snapshot up first. So just so that you could see really what we're looking at, and it's pretty intense right now. Can you see all these active regions? It looks like alphabet soup on the sun right now, but it's really just because we've just had so many different active regions pop up, and a lot of them are big flare players. 3110 is the surprise. So when I put up my forecast back on October 1st, 3110 was still reasonably quiet. Okay, it wasn't a huge nightmare, but it has since become so. And it's actually been firing, and I forget, I think 3110 is the one that has given us the X flare that we've seen recently. But we also have region 3112 or 3116. I'm not sure which one. I think it's 3112. If when I'll show you the magnetogram images of this, you'll see why the two sunspots are just completely jumbled together. They're just massive from a magnetic standpoint, and that's how I always look at them. So because that tells me what the flare potential is. And you'll see that these both have been very bad actors. And these are the reasons why we're seeing when you actually see this. And I can actually stop this right here for a sec. And I'll go into the flares first. It's actually perfect. For the solar flares and particle radiation storm issues, we're sitting at basically an 80% chance of M-class flares. In fact, we might still be sitting at M flare level right now. We just had a recent M-class flare from region 3110. In literally within the last hour. We're also sitting at about 35% chance of X-class flares. This is from SWPC right now. I have updated these for today. And as you can see, we just are riddled with a bunch of active regions. Luckily, in about 3 days, this region will rotate off of the sun's west limb. And that's wonderful news because that will lower things down just a smidge. We'll jump down to probably about 70%, maybe 65. It all depends upon how these regions out here, region 3112 and 3116, behave, and also how these fast growing regions, this is region 3117 and 3115, how quickly these regions, which you don't even see on this disk, if you watch this to the end, you'll see that they actually do show up quite quickly. As a matter of fact, let me see if I can make it go. Hang on, come on. There, you see them building right there. You can see 3017 building, and then 3015 is the region that pops up right in here. So if you've seen a recent version of the sun, which I'll show in a minute, you'll see that these regions are also very fast growing. So really, whether or not we jump down from a 70% chance of M-class flares will dictate, and of course, X-class into the 30s or so, that will be dictated by what these regions do over the next few days. Okay, so that's really what we're looking at outside of mainly region 3110. Sadly, what that does mean, however, is that we are, even though for particle radiation storms, we really aren't dealing with all that much. There's just kind of a little bit of particle radiation, just barely an enhancement that kind of quiets down because we're getting just a little bit of these tiny storms. But we do have now a 35% chance of an S1 storm here to be fired in any moment because of region 3110. this thing can produce particle radiation storms, and as it rotates to the sun's west limb, the chances of it get even larger. So that's why you see that. Once that region's gone, we'll jump down to a 10% risk. We are sitting only at the D1 minor range right now, so everything's essentially normal. So just what this means is those who are frequent flyers or those who deal with navigation at high latitudes, GPS reception at high latitudes, those types of things, just be vigilant, because at high latitudes we might have issues if we get a radiation storm launched. And that will be on top of the dayside issues you see here from solar flares. Remember, solar flares create radio blackouts. And with a radio blackout at the M level, we're talking about an R1 to an R2 blackout. For an X-class flare, we're talking at R3 level and higher blackout. These are mainly on the HF bands, but they can bother VHF as well. They can cause issues for, if we get radio bursts, they can go up into the gigahertz range, which means satellites, which means GPS, cell phones, those types of things. That is a big issue when it comes to first responders to Hurricane Ian. Just because Ian's over doesn't mean there isn't a lot of SNR, right? There's a lot of search and rescue right now. And I want to make sure that the first responders understand that they're going to be dealing with this kind of thing on Earth's day side. It's not something that Ian did. This is space weather now. Okay, we've had to deal now with these bad actors on the sun that do cause issues when it comes to GPS. So do not lose your drone simply because you haven't, you're not paying attention to the space weather and the thing goes wonky. You just have to fight with it, and just be vigilant and be aware that GPS reception can be an issue for right now, especially near dawn and near dusk when it comes to these solar flares. Okay, let me go, and now let me move it forward. Let's take a look at this. This is our solar storm and Aurora possibilities. We have at least 2 big solar storms coming, and neither of them are direct hits, but I'll talk about them in more detail in a little bit. But they're coming October 4th and they're coming October 6th. The Space Weather Prediction Center right now does not have the October 6th one modeled yet. That will likely come in the next day or so. So if you go to the Space Weather Prediction Center, and I will show their model, their current model right now, it is not yet modeled. You can find it at NASA in the Donkey CCMC database if you know where to look. I don't recommend it for those who aren't scientists, though, because it's convoluted to kind of understand what's going on. At any rate, this is my best guess at the moment for what we're going to be seeing. As you can see, it does deviate a bit from the NASA or from the NOAA predictions, but it's really based on what we're seeing in the solar wind right now. We are getting some of that fast solar wind on and off. We are getting some strongly southward magnetic field, and which is what we expected from the coronal hole that you can't see here, but it's a coronal hole that's it's now rotating in through the Earth strike zone, and we expected to get a bigger storm from it. But with all of these solar storms coming from this region, which we've seen like bits and pieces of, that's become an issue. And so the fast solar wind we were expecting has not been hitting yet. It's kind of going to be a big mess and a big jumble. So at high latitudes, definitely expect a major storm conditions. We're talking a G2 level storm easily. And then, and that's going to easily continue through the 7th. And then at mid latitudes, yes, expect Aurora on and off. I do believe minor storm conditions are going to be the norm for the next couple days, even down at mid latitudes. Will we get a G2 at mid latitudes? Maybe. We're almost there right now, and I'll talk more about that in a minute. But things should settle down by Saturday, hopefully this weekend, unless this region continues to launch and other things happen. For example, the storm on the 6th is due to this filament, and I'll talk about more about that in a moment. But for those who are looking for the 2-minute bluff, if you guys know what the bluff is, the bottom line up front, in engineering speak, this is the bluff for you. And if that's all you can stay for, then I understand. Again, this is for emergency responders, mainly for Hurricane Ian. We're going to be having, all of this time, we're going to be dealing with Aurora, and that does mean auroral propagation on Earth's night side. It does mean that we will be getting, we will have radio propagation issues on Earth's night side anywhere near Aurora, and especially anywhere near midnight. So on the day side, you're going to get these big solar flares. and radio blackouts. On the night side, you get solar storm conditions and aurora. If you are an emergency responder, if you are a hurricane watchnet, I know you can't switch frequencies, but if you guys ever need to contact people on alternate frequencies, on Earth's day side, to mitigate the radio blackouts, switch to higher frequencies, okay? Because higher frequencies are less affected by solar flares and radio blackouts. If you are on the night side and the solar storms that are hitting now are causing you issues, switch to lower frequencies on Earth's night side. Okay, solar storms, you can ride them out better when you're on lower frequencies. I know it's odd and it seems strange, but that's what we're dealing with right now. Okay, another thing is, at least, well, I probably shouldn't say that because of the aurora. Yeah, I'll just leave it at that. We don't have a radiation storm really going right now, so at least that's not impacting you near the poles. But just realize that, yes, we're going to have issues day side and night side, and this will last easily through Saturday before things get better. And it may get better on Earth's night side before it gets better on Earth's day side. Okay? So again, for those who are working first response, search and rescue, and dealing with HF radio, backup radio communications, or dealing with GPS reception for search and rescue, this is what your conditions are, okay? And also those who are dealing with satellite phones. All of that can be impacted during inclement space weather like we have now. So just be aware, keep trying, don't get frustrated, check the space weather often. And if you're a drone pilot, be sure to calibrate your magnetometer in your drone often, otherwise you get drift and all sorts of other things that you may not want while you're doing search and rescue, especially if you're trying to take pictures from on high, okay? All right, so hopefully with that bluff out in front, I will say hello to everybody. Let's see, you're running a center in Central Ohio, that's cool, okay. How long was the longest storms? I will get to that just now. I was curious to what level of X class would be disruptive to electronics. Where would we need to protect equipment? You're not going to need to protect equipment when it comes to flares. Solar flares, you don't have to worry about that stuff. What you have to worry about is actually the geomagnetic storms that occur. Those come from the solar storms. When you have a big flare like what region 3110 is doing, you see all that junk being shot out. The junk being shot out is not the flare. Junk being shot out is the solar storm, what we call the coronal mass ejection. That is what it takes a few days to hit Earth, and when it hits Earth, it causes a big storm, and that's what affects the electronics and the power grids, right? These storms, I don't think, are going to be large enough to cause us those types of issues. The big problem that if grids have any problems, it's going to be because of the duration that this stuff just doesn't go away. But if we stay at a G1 to a G2 level, we'll be fine. Okay, and I'm talking back down at mid latitudes. So I don't think that these are going to be an issue for us in terms of, I don't think these are going to be an issue for us in terms of bothering the power grids. It's just right now it's just a matter of inconveniences and more of the issues for people at Hurricane Ian, dealing with Hurricane Ian. Okay, so here is, matter of fact, sorry about this. Let me make this big. All right, so here's our sun right now, and to get you oriented, I'll wait till it resets. Come on, reset. There you go. Here's region 3110, 3113. That's old region 3107. Here's region 3112. So here you can see all of these starting around October 1st-ish. You start seeing lots of eruptions there. But do you see this one down here? That was today. Okay, that is the eruption, which I'll show a little bit later. This thing is also coming toward Earth. This is the one that has not. It's a filament eruption. It has not yet been modeled by NOAA yet. It has been modeled by NASA, and I will show that model to give you an idea. But we have several eruptions from this region that are somewhat Earth directed. One of them is definitely going to hit Earth, and that will be on the 4th. And then there's kind of a follow-up that may give us a little extra punch on kind of coming on the 5th. And then this guy gets us on the 6th. Okay. On top of that, you can see here the coronal holes, right? This is the big coronal hole that last, 27 days ago, right? Last solar rotation, this massive coronal hole gave us a lot of, and it wasn't quite the shape, but it gave us some G2 level storms just on its own, just from the fast solar wind. This month, this time, it had two active regions emerge in, in the middle of it, which began to close up the hole. And that's why the forecast changed so dramatically, because we went from expecting fast solar wind to having the fast solar wind be closed off, and now we're dealing with big massive flares and solar storms. So, what a difference a day makes. This is what happens sometimes when you get active space weather. So that's the coronal hole that we're dealing with. That's got some fast solar wind that's kind of hitting us on and off in between these storms, and so we're getting kind of sporadic. If anyone has looked at the KP data, for example, you see things burst and then quiet down and high and then quiet down, and I'll show that for you. But that's why that's happening. Okay. Meanwhile, if we look down here with this filament, now this is a dense structure, so when it erupts, this structure is going to go mainly south of Earth, but it's still the northern part of it will end up hitting Earth, it looks like. And it also exposes, once it erupts, you can see right here, whoosh, you see that it's exposing part of a southern polar coronal hole. So we have yet more fast solar wind that's going to be coming from that, a little bit of a fast wind stream that will come and hit us in and around, well, a little bit after this solar storm hits us on the 6th. So it's going to be a bumpy ride for us, okay? Meanwhile, we also have these two regions. So we have a cluster of two regions here that are bad actors, and we have a cluster of two regions here that are bad actors. So let me, as a matter of fact, let me switch to, I'm going to stop this because my computer is huffing and puffing. And I'll play this for you so you can see just how many X and M class flares we've been getting just from the paparazzi bulbs that you can see. Stand out of the way here. I probably should make that go faster, but you see. So this is region 3110. That's that you can see it pop over and over and over again, right? And then this is 3113, and then here's 3112 right here, and then you can see kind of behind it you get a little bit more. You start resolving that there's multiple regions there. And so those are the ones that really are causing the issues. Basically, none of the others have grown to any significant extent yet. So those are the ones that we're watching, okay? Now, if I pause this, and I will show you, is this it? Yes, okay. So this is how I look at sunspots mostly. I very rarely look at white light imagery. I know I probably should, but I'm much more interested in their magnetic configuration than I am in their in any other configuration. So what we're looking at here is the HMI instrument aboard SDO, and what you're looking at is essentially magnetic field either going out straight directly at you if you're Earth, or straight directly into the sun. Okay, so it's what we call the radial magnetic field, and they're colored differently. I believe blue goes in, red goes out, or the other way. I can't remember. I always get them confused because different people use different colors for different things, and I end up getting them confused. But what you don't like is you don't want to see red and blue touching each other. Okay, it's almost like a coral snake, right? Don't let red and black touch each other. Well, yeah, same kind of thing. Actually, I think it's red and yellow with the coral snake, isn't it? That's how you tell that they're poisonous and not a king snake. Sorry, it's Monday. So as you can see, this is region 3110, and you can see that we started getting some red penetrating into the blue and red in here. And between that and then region 3113 growing, this became a big long chain of yuck. Okay, so this is part of the reason why we've been having some X-class flares. However, let me focus your eyes on this. So as this set of regions goes away, even though they've taken center stage, this to me looks far more potentially frightening. And we haven't seen, excuse me, I'm going to stop it here. Let me zoom out and pull this puppy all the way over here and then zoom back in. Yes, you can get higher resolution images than this from, I'm just using the 1080p essentially. So you can see there's a lot of red and blue, and it's very, very scattered. There are delta regions in here. And so this is the area in here that we're really kind of concerned with, okay? And we're watching this emerge, watching more of that grow. And as it continues to rotate to center disk, if we get more what we call emerging flux, then this will up its potential. Right now, I think NOAA has it as about, I think this one is, this was only a 15% chance of X-class flares right now. I think it's probably a little bit higher than that, but that's okay. Right now, it's not as high as region 3110, but I do believe that this one has some staying power, especially since we're seeing these regions down here. So region 3115 and 3117 right here. These regions have just begun to really kind of emerge over the last couple of days. And the problem is that you have this dependence, this longitudinal dependence, that if you start seeing stuff growing at a particular longitude on the sun, it doesn't matter if it's northern or southern hemisphere. It means that there's something underneath the surface that's bubbling, like Rossby waves, for example. And so when a region will rotate over that longitude that's very active, what ends up happening is that it will grow too. So I'm a little bit concerned as this region rotates to some of this area in here, that we're going to see more flux emergence. We're going to see it become even more unstable, and we might see some bigger flares. So that could be an issue for us easily over the next 24, 48, maybe even 72 hours before we know for sure, because of the way this thing has been moving. I just got a notification. What? Oh, good. Another solar flare. Lovely. Okay. So hopefully that gives you some level of understanding. For those of you who want to see how we're doing, here is the X-ray flux right now. We're sitting basically, here's the sea floor, okay? So the C-class level. We are way above C-class level, right? You can hopefully see the M-class level sitting here. So we have popped just in the last 48 hours, one M-class flare, one X-class flare, another M-class flare, another M-class flare, and I think both of these are just barely M's. So we're sitting at 5 or 6 different M-class flares just over the last 48 hours. And it's been going on, as you can see, just continuing to ramp up. Luckily, again, some of this will begin to ramp back down a little bit as region 3110 rotates to the sun's far side. And we just have to worry about the risk for radiation storms for a little bit prior to that. For those of you who have been watching, radio blackouts have been prevalent all over the place over the last 24 to 48 hours. You can see here October 2nd or 3rd. So if you're wondering why, your radio communications have been a little bit dicey, this is why. Luckily, a lot of these solar flares have been fast, meaning they're not long duration. So you'll get a lot of noise on the bands. You'll get radio propagation take a dump for a short while, but then things come back reasonably quickly. And that's one of the nice things that I've been seeing with this set of active regions, both region 3110 and then 3112, is that the big flares, they're there, but then they're gone. So, again, just don't give up. Just wait a little bit. Things will get better. Okay. But we will be dealing with this kind of thing over easily the next few days. Now, right now, so for those of you who look at KP, we are sitting at G1 levels. Hopefully that'll zoom in. We're looking at G1 levels, but to be totally honest, KP is still not my favorite index. If I want to use an index that talks more about mid-latitude issues for us, really the HP30 index is an excellent one. And you can see that from here, they don't color it red until you get to much higher levels, but it's the same scale as KP. It's just on a faster time scale. So instead of doing it every 3 hours, it's now every 30 minutes. So it's a lot faster acting. So you can understand a bit more what the global changes are going on at a faster time scale. So as you can see, on October 2nd, we were sitting almost at G2 levels, and then we've kind of popped down, but it's kind of been sporadic. Because we get pockets of fast solar wind, or we get a part of a coronal mass ejection. In fact, I think this was from a strong pocket of fast solar wind. Then it got disrupted, and we had a little bit of jumble from some wake from some solar storms. And then we get pockets again of more fast solar wind. And again, right now we've been sitting in some fast solar wind again, and you could see we've jumped up to almost way past a G2 level, up to a G3 level. which is a bit different. As you can see, we've kind of settled down at the moment over the last half an hour. But this burst is why we have a KP of 5 right now. But for those of you who have been out looking for aurora, yes, there have been periods of time. As a matter of fact, just about not even 2 hours ago, where we actually had a very strong burst where we were sitting above G1 into a G2 for essentially about an hour. Okay, and this will continue probably at this level. Now, the thing is that once we get to the midday on the 4th, things could change dramatically because we have these solar storms, and I'll talk about those in a second. Looking at AE index, for those of you who know AE, same kind of thing. We're getting lots of substorms, but we're not probably really at a huge geomagnetic storm level yet. And the reason why is because we just get these bursts that calm down, and then these bursts that calm down. Anything above 500 is a good solid substorming. So that was a good burst. That was a good burst, but it's not sustained. Okay. So, you know, those of you who are at mid latitudes looking for aurora, it's going to be sporadic yet, and it will likely be sporadic until about the 4th, when we might actually get some real sustained stuff. Right now, this is just, like I said, it's that solar wind, that fast solar wind that's trying to penetrate, and it's getting kind of blocked off a little bit by basically the edges of solar storms that we've been seeing. And that's, like I said, going to continue probably for the next at least 12 hours, I would think. Okay. Do I want to take time doing that? No, probably not yet. Let me go ahead and grab this. I'm going to show you kind of what we're talking about here. Let's do this one. All right. So this is an annotated. Oh, I probably have to make it. Well, yeah, I'll loop it for the moment. All right. Ugh. All right, so this is the Space Weather Prediction Center. I'll set that here. Hopefully it'll go away in a sec. This is the Space Weather Prediction Center's model. This is what you can see right now. It has all but one of the coronal mass ejections that we're looking that are Earth directed. So you can see back right around the 1st, we had just boom, 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 boom. There's just lots of stuff coming out. There's only 2 main ones that are these big guys as they'll launch again. I will stop the movie in just a minute. But when it resets and you see it launching, there's basically one that's kind of Earth directed, and then another one that kind of comes out right behind it. You see those 2, and then in this model, they merge. In real life, they just compress each other. They won't merge. These models are we have to simplify them in order to make them run faster than real time. So don't take it with a grain of salt. These aren't cannibalizing CMEs. It doesn't really exist. But because of this particular solar storm, the edge of it, the eastern edge of it, is going to hit Earth. It looks like this thing is going to get quite intense. Again, take that with a grain of salt. And for those of you who are not familiar with this, we're looking down at the sun from the North Pole in this diagram. Earth is off to the right here. So we're basically looking down into what we call the ecliptic plane. In this cut here, we're taking a cut straight through, right there, cut right through the sun, basically the sun-Earth line, straight down the pie. And that's what you're seeing here. That's that slice. So you can see Earth and you can see the sun, but now you're looking at the north-south extent as opposed to a flat disk, a pancake cut right through the equator. Okay, so you can see that this solar storm mainly, north-south, it actually is a pretty good hit. It's just that it's basically going west of Earth, right? So like that, but we've got this flanking blow here. Okay, so that's what we're seeing is going to hit. And the reason why you see a double-edged or a double peak is because of the second storm kind of crashing in, creating this double peak. Is it really going to be a double peak? I don't know. I would think not, but nonetheless, and I don't think it's going to be this intense. I think it's going to be a little bit not quite this intense. We'll see. Of course, they also have the solar wind being really, really slow at front, and I don't think that's the case either. Solar wind is a lot faster than this, so you're not going to see nearly a jump up nearly this strong. So I think the solar storm, although it's going to hit us, I think they're maybe slightly overestimating how large and how intense it's going to be. But nonetheless, we do have that solar storm that's going to be hitting, and then there's one more, because we didn't talk about the one that's moving south of Earth. And I'll get to that in a sec. But notice they actually have it at basically the end of the third. Again, I think it may be overblown in terms of its speed, but right about the fourth. Okay, when NASA did their model, it was going to be coming at the beginning of the fourth. I just don't think that second CME, that might have been a faster one, is really going to impact and push this structure that much faster than it's already going. So let me show you, since we have that. Wait, let me do this. How many movies can I get up at once? Okay, let me do ISWA annotated 1006. Is this the right one? Yeah, I think so. Okay, so this is the one. So this is NASA's version of Enlil, okay? And you're still looking at the same kind of thing. It's just that now we're just looking at the density. We're not looking at density, and then the second panel down below with the NOAA one was velocity. Here it's just the density. It's just that one top panel. And I probably have to loop it. Yes, hold on. So loop, okay. So as I loop this one, so this is the one that is coming south. This was from that filament eruption, okay, that occurred today. And this is the one that that NOAA has not included yet. As you can see, you can totally tell, right? Because you're looking down at the North Pole, and you've got west and east. You didn't see any in the NOAA that was going eastward of Earth. They were all going westward of Earth. Okay, so basically we're going to get hit by around the fourth by structures that are going mainly to the west of us. Here we're going to get hit on the 6th, mainly by structures that are going east of Earth. The sun has had terrible aim, but I don't mind right now, because Ian is, I'd rather have the sun miss Earth than really, really hit us hard. So if I pause this, well, actually, let me flip over here. You can actually see in the splash down here, you can see it splashing right down over here. And if you look at my compass rose that I've got up top, you can see south is this way, east is this way. So if Earth is sitting right there, sorry, my arrow's slightly off, then the splash being here shows that it really is going to go mainly southeast of Earth, right? See, south is that way, east is that way. So that splash shows if Earth is here, it's going to go mainly southeast of Earth. Okay, that's what that splash is. It's showing where is it when it's supposed to hit Earth, where is the big hit going to be? Well, it's going to miss just a bit. Okay, but nonetheless, if I pause it at the right place, hold on. Oh, back up. Okay. When should we see it? And hopefully you can read this. About noon on the 6th is when NASA believes that we're going to start seeing the impact of it. Again, mainly east, mainly south. Okay, so it's just barely going to graze Earth. Could it miss us entirely? Yeah, possible. Do I think that's going to happen? Probably not, if for no other reason than the coronal hole that it kind of exposed is south of it, and also to the east of it. So if anything, this structure is going to be blown into Earth, and it's going to be blown northward. Okay, so it's going to be blown to the west and deflect to the west, which means it's going to deflect into Earth, and it's going to be deflected northward, which means it's going to deflect into Earth. So I think there's a very good chance that this structure will end up grazing us. And then that's going to happen, as we get through the tail end of some fast solar wind. So, man, I mean, we've just got fast solar wind. We've got these solar storms coming almost back to back. And I do believe that the Space Weather Prediction Center will end up updating their solar storm model stuff here shortly. I will go ahead and play. No, you know what? I won't play this. I will play today's. So is it playing? Okay, over and over again. So if you take a look at so just in case anyone hasn't had a chance to look at today's chronographs, this is chronograph. This is the view from Earth. So this is the SOHO LASCO chronograph. And we're looking at difference images on this side in the C2 field of view. There is the big eruption from the filament. Okay, and it is what we call a partial halo. When it shows off like that, there's a good chance that it's close to missing us, But like I said, I think it's going to be deflected into us. But nonetheless, this is not going to be a massive gray or massive blow to Earth. It should be just a graze. So very similar, maybe even a little bit less intense than the graze that we're going to get from the other solar storms that were hit on the 4th. Okay, so whew, hopefully that gives you some intense forecasting here. I'll go ahead and go again to my 5-day outlooks. Again, this is today's 5-day outlooks. Now you get to see them big instead of seeing them like we had them before. We really, at high latitudes, definitely expect Aurora. I mean, just expect it. Possibly Aurora clear in through Friday into Saturday before things really calm down. At mid latitudes, I'm putting up minor storm conditions because I think the Earth is so rattled at this point that it's just going to continue. And so even if we only get a little bit of minor storming, especially on the 5th, if anything calms down, it will calm down a bit on the 5th, and then we'll get more on the 6th. And I'm just doing my best guess when it comes to what are the chances of us getting G2 levels. Again, please look at HP30 indices if you really want to know what's going on a faster time scale than KP offers. KP is horrible for Aurora. If you happen to be an Aurora photographer, you need to use something like AE index or the HP indices. But we could get still up to active conditions through the 7th before things calm down. And again, solar storms hit the night side. So again, if you are a first responder and you're still with me, know that nighttime can be an issue for you, especially over the next 3 days. And then things should get better. But if you're having issues with radio blackouts on the day side, you can try the night side, but you'll have to switch to lower frequencies instead of higher frequencies. You may not even be able to use the actual emergency. You can use the emergency stuff on the night side, but it may work better on the night side than any of that stuff will work on the day side. Granted, anyway, I won't go into the details. When it comes to solar flare and particle radiation storm outlook, again, we're looking at 80% chance of an R1 to an R2 blackout. R3 blackouts, we have about a 35% chance. That's X-class flares. That will calm down as we move into the weekend, just a little bit, not a lot, but a lot can change. It depends upon what region 3112, and 3112 and 3112 and 3116 will do. Sorry. And then also 3117 and 15, which have been emerging quickly. They're not growing super fast, but we'll see. I mean, I never want to rule them out, but I don't think that they're going to become big flare players for us. So I think we'll be okay. And again, if you happen to be dealing with flying or dealing with anything in the high latitudes with radiation storms, just be vigilant. We don't have radiation storms right now. Everything is basically normal. We just have slight elevated fluxes from time to time. But just stay up on the space weather forecast so that you know if radiation storms are going to come. And if they come, that'll be probably within the next 3 days or so. And then we'll get a little bit of a break for about another probably another 5 days, 3 to 5 days. And then we could get another burst as region 31, 12, and 16, as they move to the west limb. Is this like drinking from a fire hose? This is what happens when space weather gets busy. Everything is thrown at you. So hopefully that makes some level of sense. I'm going to go back to my space weather snapshot here and keep that playing while we all chat. So now I will answer questions for people, and hopefully that worked for you. Okay. Miss Anonymous, I do disaster relief, and the last couple of days has been a struggle. Yeah, I'm so sorry. Just stay apprised of what's going. Coworkers think you're nuts when you bring this stuff up. I saw that. I don't see who posted that, but yes, that is, unless you're an amateur radio operator or you deal with GPS on the daily, that can be a real problem. And digital modes can do a lot better than analog modes in these types of situations. So oftentimes the hurricane watch nets have a lot more trouble when it comes to that, because you've got a lot more people that are that are not working for FEMA, and so don't have the best equipment or don't do a lot of digital, and that becomes an issue for us. So Oh, good, Jerry. Nice to see you, Jerry. I'm so glad you made it. Okay, so let's see. Thanks, Tamitha. I can never watch live. The audio cuts in and out, so we'll watch after. Wonder why. Oh, hopefully no one else is having trouble with audio. I apologize for that if it's my problem. What is the max number to the solar? Oh, the solar flux. Oh, we can get solar flux in 2 and 300. We're nowhere near that right now. So let's see. Oh, that's great. We need to get these ridiculous adult dating site things out. Don't you love YouTube? Thank you so much. Does a weakening magnetic field change Aurora? Yes, but it's not. It's going to change the location where Aurora is, and if anything, it actually helps the power grids. The power grids actually like that the Earth's magnetic field is weakening because it actually makes geomagnetic induced currents, or what we call GICs. It makes them weaker. So anybody who says that the Earth's magnetic field is because it's weakening, it's a problem for us. No, there's actually people who deal with things every day who actually appreciate that because it's actually going to make things easier on them, not harder on them. Where is the KP30? Oh, the HP30 chart. Where is it posted? The HP30 chart. Let me go to it. Hold on. This is in Potsdam. So if you go to GFC Potsdam, this is where it is. So if you could just do a Google search for GFC Potsdam HP30 or just HP index, because there's an HP30 and HP60, okay? And they're the same scale as KP. They're just higher resolution, okay? And they're still global. They're still global, but they are so what I mean by that is that they're still like a KP, a KP planetary. They're still a planetary index, so they're not local, but they're just on a higher cadence. And these are becoming, very useful because honestly, they even have a comparison on their page that if you talk about KP, which is sitting here in blue, it misses stuff. So like you can get peaks, just like we're getting now, right? We're getting peaks. This is the HP30 and then HP60 index. The HP30 really tells you where the peaks are and how big the peaks can get compared to the KP index, which can be much lower. So that's what we're seeing here is that right now, or over the last hours or 2 hours rather, we've had KP, an HP30 value of almost 7, like 6.5. Whereas if you go and you look at the KP index, right, the standard index, you're only going to see 5. Right. So this tells you that there's a G, locally for a short period, we actually peaked at a G2.5, almost a G3 level storm, whereas KP will only tell you it's a G1, right? So that's what's really nice about the KP index or the HP indices is it gives you a faster and a better understanding of where, where we are on a planetary scale. It's still not the best to use for Aurora. You really need to be using indices that are local to your neighborhood, not a planetary index, because think about it. If it's on the day side, it's not going to be interesting. There's not going to be a lot of aurora going on. The aurora is going on the night side, so it smears it out. So it doesn't give you a decent idea of what it is. What happened to my? Oh, did I kill it? I must have killed it. Let me go back to my. My outlooks, where are they? Sun Outlook. I think it's version 3. I have so much stuff. Yeah, there we go. Okay, it was still going. All right. So hopefully that answered that. It's been so eye-opening to learn a little about this stuff and realize when everyone thinks that transmission issues happen, it's not random and not the server's fault. True. There are lots of peculiars to space weather that can cause hiccups and things like that. Regarding Ben from Suspicious Observers, I will not comment openly. I think it's great that he's raising awareness for space weather, but that's about all I'm going to say about Ben. Anybody who can raise awareness of space weather is doing us a favor. I just don't like it when he talks badly about scientists because they're my colleagues. And we're the reasons why he has the data he has. Let's see. Solar stuff gets to Earth anywhere from about 8 minutes to 96 hours. No, not necessarily true. You have to be a little bit careful. Remember, there's multiple types of phenomena. So if you're dealing with electromagnetic light, you're dealing with massless particles, that's 8 minutes, right? So solar flares, radio bursts, that type of thing, and that affects the day side. The night side, you're dealing with solar storms, much slower material that can get to Earth in about 6 days at the slowest. And in the middle, bridging those two, the fast and the slow, are radiation storms, and they can get to Earth anywhere between about 15 minutes for the electrons because they're relativistic. They are particles, but they're moving at a fraction of the speed of light, to the protons, which can arrive anywhere between about half an hour to a couple hours after, to days after, because of depending upon where they were launched. Okay, if they're launched on the far side of the sun, it can take days for them to get to us, strangely enough. But those types of that's pretty detailed phenomenology. This is the reason why we can't conflate different types of solar phenomena. They all affect Earth in a very different fashion, and they all arrive at different times, even when they're launched exactly simultaneously. Okay, so it can be very, very convoluted, and to say it's just solar stuff is you got to be careful. You can get yourself in trouble. You froze and buffered when you were talking. Uh-oh, I hope I'm okay. I hope it came back, because I have no idea what part buffered. All right, let's see. 10 meters open during the day was expected, but it normally dies at night. I've never seen it open almost all night. Yeah, well, right now especially. And that's going to continue to be a problem as we move towards solar maximum. And the reason for that is because we're getting more solar storms. The nice part is that we're getting more aurora too. So the best I can say is enjoy. If your radio doesn't work, get out of your shack and look at the night sky, because you might actually see aurora, and then when the aurora goes away, go back inside and do some DX. there's always something. Hi, Lisa. Good to see you here. Why is the sun so active? Because we're moving towards solar maximum. This happens every 11 years. It's like clockwork. Don't worry about it. It's completely normal. We should peak activity should really peak around 2020, late 2024 into 2025. And then we'll begin the declining phase where things will slowly but surely get quieter. This happens, this is the 25th cycle that we've counted. That doesn't mean that's only been 25 cycles. It just means we actually have really good data for the last 25 cycles, and so we have an idea kind of what the sun is doing and how it does it, what it does its thing. But you just think of it from that perspective. If a Carrington event occurred, would you race to try and tell your viewers? Oh gosh, yes, absolutely. I'd get on, if I found that there was a Carrington class event, I would get on, no makeup, no brushed hair, in pajamas if I had to, because that's about how much time I would have. And say, if we go out and there's no power, please forgive. But, likely that's not, even if there is a Carrington class event, the chances of it clipping us as opposed to hitting us are pretty big. But you didn't know there was a Carrington class event that hit us back in 2017. Didn't know it because it was a flank, just a glancing blow. But it was basically Carrington class, and it was during the September 2017 events, during the second largest, what we called the second largest solar flare of cycle 24. It likely was the largest, but the reason why we don't call it the largest is because from Earth's perspective, it wasn't the largest. The active region 2673, was actually rotated to the sun's far side, and we barely saw part of it. It was kind of what we call occulted, blocked by the sun's west limb. And so it launched a huge flare. It launched a solar storm that was a Carrington class, or damn near a Carrington class. And the thing was so big that it ended up hitting Earth, even though it was launched away from Earth. That's pretty intense. So yeah, Carrington. We live with Carrington class events all the time. So don't be as frightened of them as the media wants you to be. They're just a part of life. Okay. Solar cycle 19 here. Well, let's hope not. If you're an amateur radio operator, yes, solar cycle would be great. 19 would be great, but I don't want another 1989 event, to be totally honest. So that's when we know it's bad, right? Right. Okay. Oh, good. I'm so glad you were able to catch me live for the first time. Hello from the Netherlands. That's wonderful. Go to bed. It's probably late, really late. Oh, thank you, Chris. That's very kind of you. All right, you thought I was in my pajamas. Yeah, it kind of looks like it, huh? How does, okay, this is Jonathan saying, hi, Tamitha, how does a cycle compare to the past few cycles? This cycle is actually ramping up faster, and it's more intense. So I think it's going to be bigger than cycle 24. I think Scott McIntosh and the NCAR, UCAR crew are correct. Will it be a cycle 19 though? I don't think so. No, I don't think it's going to be big enough. It's going to be somewhere around what the median cycle is. So what that means is that big events are still on the menu. Including the biggest, including Carrington class events, because usually it's the smaller cycles, the smaller or average cycles that give you the Carrington class events, because the magnetic field of the sun is still kind of a mess, but it doesn't give us like the most extreme events like all the time, like bigger cycles do. So, again, everything in space weather is a mixed bag. There's always good things and bad things. You love that fire hose. That's cute. Okay, let me check to see on Patreon if there are any questions. So if any of you are Patreon members and you have asked me a question, feel free to post it on the Patreon feed. Oh, hi, Mike. Michael Wallace, 59 in the UK. Good. I'm glad my signal was okay. Joseph Anthony says, will radio ham bands suffer due to these flares today? Oh my gosh. And in the near future. Yes, easily through Saturday. Only on the day side, right? It'll through Saturday. Actually, maybe longer on the day side. Night side, it's going to be really bad from the 4th essentially to the 6th or 7th, and then things will calm down. So hopefully that clarifies that. What class was the 2017 event? It was X. The one that was on the sun's west limb. That was an X 8.2. The bigger one was an X 9, I think, which happened when that same region was on the front side of the disk, but didn't launch a solar storm at that time. So, yeah, 1989 SFI hit 250. Yeah, exactly. It was a blast, but emergency comm was very touchy, right? And 1989 in March was when we had what we call the standard candle. For solar storms. It woke us up to why we needed to really do space and take space weather forecasting seriously, because that was when the Toronto Stock Exchange went down. That was when we had the Quebec, Hydro-Quebec and the James Bay network go offline. Billions of people were without power for like half a day. It was pretty bad. So it was like, oh, maybe we need to pay attention to these things. So will be an X-flare, a massive CME that will affect us worse. Well, X-flares don't really cause that much trouble. They block out our communications for a bit, and as long as we know that it's a flare and not an aggressor, we're fine. In 1969, we almost went to a world war because we didn't realize it was the sun blocking our radio communications until we figured it out. But really, solar flares don't really damage things. It's really the solar storms that come and damage things. So anytime you're worried about infrastructure on the ground being impacted permanently, that's all solar storms, whether it's the health and safety of spacecraft or its impacts on the ground. It's the big solar storms that cause that, and fast solar wind when the material actually reaches Earth. The solar flare is that's just the sun screaming. So basically, satellites can chirp all they want, their little cricket chirps. And if the sun is screaming loudly, you're not going to hear it. It's that cricket in the train tracks thing I keep saying. Okay. Any other questions that especially, okay, I'll answer this one. I've been hearing a lot about the South American, you mean the South Atlantic anomaly? Can you give us more information? The South Atlantic anomaly is basically the inner part of the inner Earth's radiation belt. It's not really an anomaly other than the fact that it causes a more intense amount of radiation to be I don't know, focused. What is the word I'm looking for? To be experienced, to exist over basically this part, the eastern tip of South America, over the ocean there. And the reason for that, again, is the Earth's magnetic field is tilted relative to the Earth's geographic pole, the magnetic pole is tilted. And that causes, if you have radiation belts, it causes them to tilt. And that means the inner part of one in the southern hemisphere actually comes lower down into the Earth's atmosphere than the rest of the radiation belts do. And that's what causes that quote unquote anomaly. So it is a feature that is persisting. As Earth's magnetic shield changes, that anomaly is moving, right? Makes sense. The Earth's magnetic field orders everything, including where the radiation belts are. So as the Earth's magnetic field changes, that anomaly is changing as well. Is it getting more intense? No. As a matter of fact, when the Earth's dipole field goes away, the radiation belts are going to change dramatically. Space weather is going to be fun. As a matter of fact, I'm not even sure really what kind of stable configuration we're going to have for radiation belts at that time. But don't worry, we've done it. The sun does it every 11 years. So, and the Earth does it every couple 100,000. So don't worry about the Earth's magnetic field flipping. Like I said, the sun here, this thing does it every 11 years. And as a matter of fact, it's doing it right now. That's why it's getting active. Okay. Once we get to solar max, it won't even have a dipole field. It'll be in the middle of its flip, and dipole field will have gone to 0. Okay, guys. Any other questions? See you on the next rotation. Yeah. Good evening from Sweden. Good to see you from Sweden. Good, guys. When will the maximum SFI be? That's hard to say, but probably close to 2025, somewhere in there. Yes, it's like clockwork for your wife's migraines. Yeah, sorry, there are some people who are susceptible. I do understand that. Solar flares and solar storms, they'll affect people who are sensitive differently. So definitely learn more about the different types of space weather phenomena, because that might help you. It might arm you with information. And we're working on a medical database that can help you guys out. It's still in progress, so stick around for that. But we're basically taking a lot of the PubMed publications and organizing them in such a way as to help you guys basically arm yourselves with the kind of information you need to be able to go to your doctor and say, hey, is this making sense? And just kind of giving yourself as much information as you can. So hopefully that will help. Okay, guys, where can we order good weather? Oh, sorry about that on Saturday. Hopefully things will be better, Flipster. I sure hope things will be better by Saturday. They may, in fact. So, okay, guys. It looks like I've answered pretty much most of the questions here. You're very welcome. Thanks so much for joining in, and I hope all of your loved ones are safe and healthy. Okay, I'll talk to you soon. Okay, bye.